Work and voltage. Your primary questions for this video are: what is the relationship between work and voltage, the title of this video? Why do we have both 110 volts and 220 volts in our houses? We actually have more at school, but we'll talk about that more in class. And what are some different ways to think about voltage? Simple term, but many different ways to think about it. All right, so work and voltage. First, some definitions. Work is required to push a small positive charge against the electric field around a positively charged sphere. So this goes back to the field that we were talking about before and a test charge. And if we have a positive test charge and we have an electric field around a positively charged sphere, if we try to push this test charge towards the positive field, it's going to require us to do work in order for us to push it towards the positively charged sphere, like this drawing shows. Now, therefore, since work is done on the little charge, its potential energy, its PE, increases. Right? Work is going to be the force times the distance. Work is energy, and in this case, it's going to be stored energy. So this is going to be its potential energy, its electric potential energy. Now, the closer it gets, the more strongly it is repelled by the field. Therefore, as you get closer and closer, more and more work is required. Now, what's interesting about this is if the little charge, the little test charge, gets close enough to the sphere to be added to it, the charge on the sphere increases, and when the charge on the sphere increases, the field around it becomes stronger. So the greater the charge, the stronger the field. And this goes back to the last video. Now, if it's not added to the sphere, and the charge were simply released inside of that field, it would move away from the sphere and its potential energy would decrease as it is being converted into kinetic energy. So if you just release it, all of that work that was done, that was stored in the electric potential energy, is now converted into kinetic energy, meaning that the particle, that test charge, will move based off of the electric field lines at that point. So, some more definitions. The amount of work done per unit charge as a charge is moved between 2 points in an electric field is called potential difference. This is what we also call voltage, and this goes along with the unit. The unit for potential difference is the volt. Potential difference is often called voltage, and we use the symbol V. So the equation that we use for calculating voltage, based off of this definition, is V is equal to W over Q, the work per unit charge. So V is the voltage, W is the work, Q is the charge. V is equal to joules over coulombs, or joules per coulomb. And so the way we can think about 1 volt is equal to 1 joule per coulomb. Since work done on a charge and the gain in potential energy of the charge are the same, the voltage can be thought of as work per unit charge, what we just talked about from the previous slide. Now, what this tells you is the greater the voltage, the greater the work that can be done per unit charge, per coulomb. So depending on what you need to do, you can increase the voltage to be able to do that work. Or if you don't need that much work done per charge, you can use a smaller voltage. This is why for almost everything, we have different voltages for different appliances, different devices. The batteries in our laptop or in your iPad are going to be different than the batteries used in flashlights, or the battery that's used to power an uninterruptible power supply that's used to power up your entire desktop computer, or the voltage for your computer compared to the voltage for your dryer or for your range, or when you talk about industrial scale machinery for 3-phase motors, things like that. The voltage tells you how much work you can do per charge. So the more work that you need to be able to do, the greater the voltage you need to have. All right, a simple practice problem. If you do 13 joules of work to push a 0.0030 coulomb charge from point A to point B in an electric field, what is the voltage difference between points A and B? And we'll work on this in class.